Welcome back. Let's talk about the distance formula. So the distance formula you're going to see in class is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And that's going to be equal to distance. This looks scary. It looks complicated. It looks like there's a lot of steps there. But let's talk about where it comes from. If I have a point here, we're going to call it point A, and I have a point here, we're going to call this one point B. There is some distance between them. And the way I would find this distance is I need to know how far to the left or right I traveled, and I need to know how far up and down I traveled. And would you look at that? That looks kind of like a right triangle. If we have our distance from left to right and our distance up and down, those are perpendicular to each other. In other words, they form a right angle. So the distance formula is actually a rewritten form of the Pythagorean theorem, which is a squared plus b squared is equal to c squared. In this case, a squared is the distance that I traveled from left to right. The way we find a distance is we subtract 0.1 from 0.2, or 0.2 from 0.1. It doesn't really matter as long as you absolute value them and make sure that the value is positive, because distance is always positive. So that's what we're doing here in this first part of the distance formula. Is we are saying this is the second value of x that I wound up at. This is how far from left to right I traveled. And then I'm taking that value and squaring it. I'm taking that distance a and I'm squaring it. Then I have my b value, which is how far up and down I traveled. So I take the difference of my heights and square that, and that's my b squared. And then finally, this distance overall is c. And in order to find c, we would have to square root both sides. So we would square root both sides, and this square root would get rid of this square root. So this square root would get rid of this square. So we wind up with the square root of a squared plus b squared is equal to c. And that is where the distance formula comes from. It's just a fancy looking Pythagorean theorem. So let's apply it and see how it works given two different points. The first one we're going to look at is going to be from point -2,3 to point -7, -7. All right. So remember, we're looking for how far did we change from left to right and how far did we change from top to bottom. We're squaring those values, adding them together, and then square rooting it, following the Pythagorean theorem. And I'm going to have both of those written off to the side real quick. So a squared plus b squared is c squared, and distance is equal to square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. All right. Remember, these are essentially the same thing. So how far did I change going from left to right? Well, I went from -2 to -7. So I changed a total of 5. It was 5 in the negative direction, but we care about the distance, and the distance is always positive, so I'll take the absolute value of that. I changed from left to right 5. That's my a value in the Pythagorean theorem. So I'll square that because I'm going to take that distance and square it. Now, how far did I change going up to down? So I went from 3 to -7. That's a total distance of 10. So I need to square that 10. 5 squared is 25. 10 squared is 100. Adding those together, I get 125. And finally, that is equal to my c squared. I need to square root both sides in order to get the actual distance. So square rooting both sides, whoops, that should just still be an equal sign. we're going to get c is equal to the square root of 125. Now, you could leave it like this, but that's not fully simplified. To simplify this out fully, it would be 5 times the square root of 5. If you would like a video on how to simplify or reduce square roots or radicals like this, please let me know. I'm more than happy to make one. But this video is just about how does the distance formula work, so I won't get into the nitty-gritty of how simplifying radicals works. For our second example, and I just realized that this is getting cut off, so let's write it down here. A squared plus b squared equals c squared. There we go. For our second example, let's take a look at what happens if we go from -10, -7 to -8, 1. So what is the distance I traveled left to right? Well, the distance I traveled is 2. The distance between -10 and -8 is 2. So left to right is 2. How far did I travel up and down? I went from -7 to 1, which is a total distance of 8. So I need to take my distance of my x distance, square it, my y distance, square it, and that's going to be 4 plus 64 is equal to 68. And finally, because we're looking for c in this case, we need to square root both sides, or we need to square root this to get c. So square root this, square root this. Our actual distance, because remember, distance is the same thing as c here. These are the same. Terrible arrow. These are the same. Our distance is going to be the square root of 68. And simplifying this down is going to be 2 times the square root of 17. And that is the distance between this point and this point, is 2 times square root of 17. Let's take a look at just one more today. Oops, gotta erase this point too. The last one we're gonna go through today is 8, 5 to 1, 3. What's the distance between these 2 points? Well, my change on the x-axis, so how far I went left to right, is 7. And how far I went up and down is 2. I need to square both of those values and add them together. So this will be 49, this will be 4. Added together is going to be 53. And then we need to square root the 53, because the 53 is the same thing as c squared. We need to square root it to find the distance. So our actual distance is going to be the square root of 53. And I don't believe 53 can be simplified. So that will be our final answer. That's all the examples I have for you today. If you found this video to be helpful, consider liking and subscribing. And if you have a topic you would like for me to cover in the future, leave it down in the comments below. As always, have a fantastic day.